Assalamu alaikum. Dear student, as you know that we have discussed different separation technique like solvent extraction, micro extraction, solid phase extraction, even pre-concentration. Today the topic of our discussion is chromatography. I will recommend these two books. One is J.D. Christian, Analytical Chemistry 7th edition. Other one is Kuj and West, Fundamental of Analytical Chemistry 9th edition. First of all, question is, what is chromatography? The word chromatography is basically derived from the two Greek words. Chroma means color and graphium means to write. Chromatography is basically laboratory technique used for the separation of different components of a mixture on the stationary phase by passing mobile phase through it. So chromatography literally means color writing, was used and named in the first decade of 20th century, primarily for the separation of plants pigments such as chlorophyll. So while coming to the principle of chromatography, basically in chromatography, as I mentioned it, different components of a mixture are separated. So different components of a mixture partition themselves between the two phases. The different components of the mixture are basically dissolved in a mobile phase, and then this mobile phase along with these different components are passing through the stationary phase. So the different components which are dissolved in the mobile phase develop interaction with mobile phase as well as with the stationary phase. The interaction of these components in the mixture with mobile phase and stationary phase are different. So it means that on the basis of this thing they are separated from each other. What does it? It means that there are two phases in chromatography. One is this mobile phase, as the name indicates, the phase which is moving, the phase which dissolves these different components of a mixture, inside it. The phase which is moving is known as mobile phase, while the other phase is the stationary phase. It can either be a solid matrix or liquid embedded in the solid support. The phase which is not moving. So it can be either liquid or it can be either solid. So these different components of a mixture along with mobile phase is passing through the stationary phase. Then these different components present in the mixture develop different kinds of interaction. These interaction can either be a physiochemical principle such as adsorption, ion exchange, molecular sieving, and affinity, etc. So while classifying chromatography, there are different modes of classification of chromatography. Here we discuss these two modes of classification. One is based on the interaction between sample component and a stationary phase. So this interaction, on the basis of this interaction, the chromatography, either it can be partition chromatography, adsorption chromatography, yield filtration chromatography, affinity chromatography, ion exchange chromatography, and so on. While coming to the how the stationary phase is held, there are two types of chromatography. One is this planar chromatography and the other one is column chromatography. If the stationary phase is held in the form of plane, then this type of chromatography is known as a planar chromatography. But if the stationary phase is held in the form of column, this is known as a column chromatography. So first we discuss this planar chromatography. If the stationary phase is held in the form of plane, it can either be paper chromatography or thin layer chromatography. So first we discuss this paper chromatography and planar chromatography. So paper chromatography is basically an analytical technique used for the separation and identifying mixture that are either color or even can be made colored. This paper chromatography is a type of a liquid partition chromatography. This can be used for the separation of amino acids, sugars, sugar derivatives, and peptides. Usually, our students get confused that in paper chromatography, the stationary phase is paper. No, it's not. In the paper chromatography, the stationary phase is water. This is a type of chromatographic paper. This is a paper. So the stationary phase is water held on a solid support, filter paper, cellulose. The mobile phase is a mixture of immiscible solvent, which are mixture of water, nonpolar solvent, and acid or base, butanol, acetic acid water, or phenol water ammonia system can be used as a mobile phase. So what is the procedure of a paper chromatography? So you have this chromatographic paper. First of all, like a line is drawn in the bottom of this chromatographic paper, just like 1 or 2 centimeter away from the bottom of the chromatographic paper. So a small spot of a mixture which is containing these different components of a mixture is applied to the strip of this chromatographic paper about 2 centimeters from the bottom of the paper plate. The sample is absorbed onto the paper and may form interaction with it. This chromatographic paper is then dipped in a suitable solvent, whatever mobile phase solvent you are using, so such as ethanol or water. But taking care, this chromatographic paper is not dipped. Specifically this where you have applied your sample is not dipped in this solvent system. So taking care that the spot is above the surface of the solvent. This spot where you have applied is above the solvent, and then is placed in a sealed container. Then what happened? This solvent moves up through this filter paper, this chromatographic paper, through the capillary action, and dissolve this sample mixture, and then this is going through this stationary phase. In this different components present in the mixture. So here in this picture you can see these different colors considered different components of the mixture. So develop different types of interaction with mobile phase as well as with the stationary phase. And these different components are basically moving through this stationary phase. As the interaction for these different components is different, so they are separated on the basis of these different interaction with mobile phase is with the stationary phase. So different components in the mixture travels at a different rate, as I mentioned it, due to the difference in the solubility of these components in the mixture, and the difference in the interaction of these components with the to the fiber in the paper, to the water in the paper. So how much time it takes this paper chromatography? It can take from several minutes to even several hours. So once you do this chromatography, so you get this piece of a paper having these different spots. These different spots corresponds to the different components of a mixture. This paper is known as a chromatogram. So in this paper chromatography there are two types of chromatography again. One is this is an example of ascending chromatography. So in this method the solvent is in the pool at the bottom of the vessel in which the paper is supported. At the bottom of the vessel in which paper is supported, it rises up by the capillary action against the force of a gravity. But substances that can't be separated by ascending method can be separated by descending method. So what is their descending method? In descending chromatography, the only difference between ascending and descending chromatography, here in this ascending chromatography, the solvent is in the pool at the bottom of the vessel is going up by the capillary action, while in descending chromatography the solvent is kept in the trough at the top of the chamber and is allowed to flow down. So the chromatograph, this solvent is going down by the capillary action as well as by the gravitational force. So it means that capillary action and gravitational force are in the same directions. So after doing this paper chromatography, after developing the spots to the different compounds, these spots corresponds to the different compounds present in the mixture where you have applied. So these different compounds are separated. This can be maybe located by their color, ultraviolet light, non-hydrogens, or by treatment with iodine vapors. So it can be visualized in. The paper remaining after the chromatography is known as chromatogram. So these different components are separated. The difference between these components of a mixture, that they have different RF values. What is RF? RF is a retention factor. So what is this RF value? The retention factor is the ratio of the, basically this RF value is, this is the ratio of the distance traveled from the spots or origin by the solute component and to the distance traveled from the spot or origin by the solvent. So basically this RF is the ratio distance traveled by any component to the distance traveled by this solvent. So the RF value for the different compound component is different. So the maximum value of RF can be 1 and the minimum value of RF can be 0. If a component having RF value 0, it means that this component have not developed any interaction with the mobile phase. It means that this is not going with the mobile phase. And if the RF value for any component is 1, it means that they have not developed even interaction with the stationary phase. It is going with the mobile phase without any interaction. So usually the RF value for the different component is less than 1. So sometime the component of the mixture are not well separated by this one-dimensional chromatography by a single run. So what people do, people just change the direction. Like this is going to this one, and then in the second run you change the direction of this paper perpendicular to the first one. Then this type of chromatography is known as a two-dimensional chromatography. So what is the significance of a paper chromatography? Paper chromatography is a very simple, very easy and rapid technique. Initially it was a very high efficient technique, but nowadays more sophisticated techniques are there in the market. So this the quantity of the sample is used in a microgram, means a very small quantity is needed in a paper chromatography, and this can be used for the separation of a wide variety of compounds like amino acids, oligopeptides, sugar derivatives, steroids, vitamins, some alkaloids like penicillins, tetracyclines, streptomycins, etc. This is not preferred for the separation of proteins because they are not soluble in many of the solvent system, and paper chromatography is inferior to the thin layer chromatography while in resolving power. So the next is thin layer chromatography. Thin layer chromatography is also a chromatographic technique, is also a type of a planar chromatography. This is routinely used by a researcher in the field of phytochemicals, biochemistry, for the identification as well as mostly for the identification purposes. Because this is a semi-quantitative technique. This you can say, like nowadays people are using high performance liquid chromatography. Uh, so uh, this thin layer chromatography was initially used for the identification of compounds in a mixture. So what is the principle of a thin layer chromatography? This is thin layer chromatography is similar to the other chromatographic techniques. Like this one is also having a stationary phase as well as a mobile phase. The separation depends on the uh, relative affinity of a compound towards stationary and mobile phase. So it contains the stationary phase of a thin layer, adsorbent, usually like silica gel, aluminum oxide, or cellulose immobilized onto a flat inert carrier sheet. And a liquid phase consisting a solution to be separated is dissolved in appropriate solvent and is drawn up plate via capillary action. So this thin layer chromatography is having different components. So TLC system, like we usually call this TLC system, consists of TLC plates. These are the TLC plates. So these TLC plates preferably ready made with a stationary phase, like it is available in the market or in ready-made. These are stable and chemically inert plates where a thin layer of stationary phase is applied onto its the whole surface. The stationary phase on the plate is having a uniform thickness and is in the fine particle size. And the second components of this TLC system is TLC chamber. This is a TLC plate. This is a TLC plate, and this is a TLC. This is the whole is a TLC chamber. So this is used for the development of a TLC plates. The chamber maintains a uniform environment inside the proper development of a spots. It also prevents the evaporation of a solvent and keeps the process dust free. And the next one is a mobile phase here in this chamber, the third component. This comprises of a solvent or a solvent mixture, whatever you are using the mobile phase. The mobile phase should be a very having a highest purity for the proper development of a TLC spots. So the solvents recommended are chemically inert with sample in a stationary phase. So how these plates are basically prepared? TLC plates are usually commercially available with a standard particle size and ranges to improve reproducibility. They are prepared by mixture adsorbent like silica gel, aluminum oxide, with a small amount of inert binder like calcium sulfate, gypsums, and water. Then the mixture is well spreaded in a uniform way on this plate in a form of thick slurry, usually glass plate. Thick aluminum foil or even plastic can be used. The resultant plate is then dried and activated by heating in oven for 110 degrees centigrade for 30 minutes. The thickness of the adsorbent layer, what is the thickness of the adsorbent layer, is from 0.1 to 0.25 millimeter for analytical purposes, while for the preparative purposes it can be from 0.5 to 2 millimeter for the preparation of these TLC plates. So the stationary phase is applied. So what is the procedure of thin layer chromatography? The stationary phase is applied on the plate uniformly and then allowed to dry, and then you activate it in oven for 30 minutes. And then with a pencil, like just like in paper chromatography, this process, the procedure is similar. With a pencil, a thin mark is made at the bottom of the plate. Then apply a sample, a spot of the sample over here. So then this plate is placed in the chamber where you have already placed the mobile phase as well. So then these component of this mixture along with this mobile phase by the capillary reaction is going up, and these different components of the mixture are then develop a different interaction with mobile phase and stationary phase, and the different component, different spots are separated on the TLC plates then there, and then by you, it means that you get this chromatogram, and the rest of the procedure is similar to the paper chromatography. Then you calculate, then you measure the RF value of the different spots for the different corresponding to the different components of a mixture. So the advantages of this thin layer chromatography is it is a simple process with a short development time. It helps with the visualization of separated compound spots easily. You can see it. The method helps to identify the individual components easily. It helps in isolating most of the compounds. The separation process is faster and the selectivity for the compound is higher. Even a small difference in chemistry is enough for clear separation. The purity standard of the given sample can be assessed easily. It is cheaper chromatographic techniques. So the application of this thin layer chromatography is used to check the purity of a given sample. Identification of compound like acids, alcohol, proteins, alkalides, amines, antibiotics, and many more can be identified by TLC. To evaluate the reaction process by assessment of intermediate, it's usually the organic chemist during the synthesis of any compound. If you want to check the intermediate whether this compound has been synthesized or not, so people are using this TLC plates. Being a semi-quantitative technique, TLC is used more for the rapid qualitative measurement than for the quantitative purposes. But it's due to its rapid result, easily handling and inexpensive procedure, it finds application as one of the most widely used chromatographic techniques in chromatography. So we have discussed this paper chromatography as well as thin layer chromatography.